Welcome. In this project, we'll explore the power of transistors and their role in building fundamental logic gates. Transistors are the backbone of modern electronics, enabling everything from basic circuits to advanced computing. For the first part of this video, we'll discuss how transistors work, their components, and their real-world applications. Then we'll demonstrate 4 essential logic gates: AND, NAND, NOR, and NOT, using LEDs, push buttons, and transistors. Transistors are semiconductor devices that act as electronic switches or amplifiers. They consist of 3 main components: the base, the control terminal that determines where the transistor is on and off, the collector, the terminal which current flows in the transistor is active, and the emitter where current exits. There are 2 common types of transistors: NPN transistors, and these allow current to flow from the collector to the emitter when a small current is applied to the base, and PNP transistors. These work in the opposite way, requiring a low base voltage to activate. Transistors are found in almost every modern electronic device. Some key applications include microprocessors, amplifiers, switching circuits, logic circuits, and now let's move on to demonstrating the logic gates built using transistors. Each logic gate in this project is built using transistors, push buttons, and LEDs. We will observe how they function in real time. The AND gate outputs a high signal only when both inputs are high. This is achieved using 2 transistors in series, where both must be active for the circuit to complete. The NAND gate is the inverse of the AND gate. It outputs a low signal only when both inputs are high. This is implemented by adding an additional transistor that inverts the AND gate's output. The NOR gate outputs a high signal only when both inputs are low, meaning no buttons are pressed. It uses transistors in a parallel arrangement to prevent current flow unless both inputs are inactive. The NOT gate, or inverter, outputs the opposite of the input signal. If the input is high, the output is low, and vice versa. A single transistor is used to achieve this inversion.